So today we're going to cover section 6 from chapter 9, and today we're going to learn how to solve right triangles, as well as do a few more word problems. So what we're going to cover today, and we sort of saw this when we went to go do number 10 on that practice A. Whenever you're looking for an angle measure, you're going to be using the inverse trig ratio. And this is where we need to hit our second key or our shift key on our calculator. So here when you read tangent -1, this is read as the inverse of the tangent. So when we look for an angle, we're always going to either bring this up on our calculator, either sine -1, cosine -1. It's all going to depend on what sides they give us. So whenever we do this, we're looking for an angle measure. And again, we would set it up in the same ratios. Sine uses opposite and hypotenuse. Cosine uses adjacent and hypotenuse, and tangent would use opposite and adjacent. So let's try a word problem. So here it says, draw a diagram showing a person who is 1.5 meters tall, standing 20 meters from the base of a building. Also show that the person sights the top of the building with an angle of elevation of 58 degrees. Find the height of the building. So let me do my rough drawing. I'm not a very good artist. I'm going to draw my little stick figure here. So here's the man, and he's standing at the base of a building, and he's 20 meters away. So here's my building. Add some windows. You don't have to do a detailed drawing. So it says that he is standing here, and he's 20 meters away. So from here to here, it's 20 meters. And then here's his line of sight, if you look straight horizontally. And then it said the angle of elevation to the top of the building is 58 degrees. How tall is the building, or find the height of the building? Now, and it also told me that this man over here is 1.5 meters tall. Now, because his eyes are not down on the ground, I need to take into consideration his height after I do the trig ratio for the triangle. So what I'm going to do here is I'm going to find this piece of the building. I can call it H. Once I get that H, I need to go back and add in the man's height. So let me go ahead and figure out which trig ratio, and here's my right angle, uses this side, and then this side over here is going to be a 20. So I need to label these in relation to the 58 degrees. So across from the 58, this H is going to be opposite, and the 20 is going to be adjacent, because my hypotenuse is over here. So the trig ratio that uses opposite and adjacent is going to be tangent. So I'm going to be doing the tangent of 58 is equal to opposite over adjacent. I'm going to solve for that piece of the height of the building by multiplying both sides by 20. I'm going to do the tangent of 58 and then multiply it by 20. If I round to the tenths place, once I do this on my calculator, I get 32.00. So I'm going to just round it to 32. Now that's only for this piece of the building. Remember, you need to go back and add in from the man's line of sight. So my final height of the building is going to be 32 plus 1.5. So the height of the building is 33.5 meters. It says, when the sun's angle of elevation is 38 degrees, a building casts is 38 degrees. A building casts a shadow of 45 meters. How high is the building? So if I make my sun here, and he's made the angle of elevation is going up to the sun. Here is my building. And the shadow is over here. Is that blue showing up? Yeah, this is the shadow. Maybe I can go here. So this is the shadow, and the shadow is 45 meters. The angle is in here, 38. And it wants me to figure out how tall the building is. Again, I can call it H for height here. So again, I need to figure out which trig ratio, again, is going to use opposite and adjacent. And again, I'm going to use tangent. So I'm going to be doing tangent of 38 is equal to opposite, which I called H, over adjacent, which is 45, the shadow. To solve, I'm going to multiply both sides by 45. And the height of my building is going to be 35.2. If it says to round to the nearest foot, 35 meters. Or if it says to round to the nearest meter. It was just more practice of angle of elevation. Now we're going to actually do what they're asking us to cover in this lesson, which is solving a right triangle. When we solve a right triangle, I am going to end up finding all three angles and all three sides. So here it says you're going to be finding all of the unknowns, all the unknown side lengths and angle measures. So for example, if I draw a triangle here, and I call this ABC, and then if I put little a across here, little b here, little c, when I'm done, I should know the measure of angle A, angle B, angle C, little side or side A, side B, side C. So when I'm done solving a triangle, this is what I should end up with, 6 answers. Generally, 2 or 3 pieces are, you're either going to know 2 side lengths or 1 side length and 1 acute angle measure. So they're going to give you 2 of these 6. You need to find the other 4. So let's try it. So it wants us to solve the right triangle. So what I'm going to do here is I'm looking for the measure of angle A, B, and C. Let's do the angles first. Generally, when they give you one of the acute angles, to find the missing acute angle, it's easy. You just subtract it from 90. So I need to be filling in the measure of angle A. They gave it to me. It's 42. I need to find B. The way I'm going to find B is I'm going to subtract 42 minus 90. And I end up with 48 degrees. And then angle C is the right angle. So I've already found a good portion of my answers. I need to now make sure I end up with 3 sides, A, B, and C. I'm going to label little a over here across from the angle A. Little c is across from the angle C, and then little b will be over here. Well, I already have little b. They gave it to me. It's 70 feet. So now to find sides A and C, I need to figure out which trig ratio I'm going to use. So let's go ahead and identify the names based off of the acute angle that was given. So based off of the acute 42, little a here is opposite, little c is the hypotenuse, and little b is the adjacent side. So now when I want to find little a, I'm going to go here, and then I'm going to also go and find the side that has a number, and that's the adjacent side. So now I have to figure out which trig ratio uses opposite and adjacent, and that's going to be tangent, TOA. So I'm going to do tan of 42 is equal to opposite over adjacent. I'm going to solve for little a by multiplying both sides by 70. And little a, once I do tangent of 42 times 70, I get 63.02. So I'm going to round it to the nearest degree. So, I'm sorry, it's not a degree, it's a side length. Let's round it to the tenths place. So 63.02 is just going to be 63. Now let's find the hypotenuse. Yes.
How do you know to use tangent could you use cosine because you have the hypotenuse.
Okay, so I don't know the hypotenuse yet. I'm going to use, to find C, I'm using cosine.
Okay.
Yes. I have to use two different ones.
Okay.
Okay, so now to find the hypotenuse, I'm going to be doing cosine like she said, because C is the hypotenuse and the number that was given to me was adjacent. So the trig ratio that uses adjacent and hypotenuse is cosine. So I'm going to be doing cosine of 42 is equal to adjacent over hypotenuse. This time my variable's in the denominator. So I need to get that variable out of the bottom by multiplying both sides by C first. And now I'm left with cosine 42 times C equals 70. I'm going to divide both sides by cosine 42, giving me C is equal to 94.19, rounded to the tenths place, 94.2. And again, it makes sense because your hypotenuse is the biggest side. So this answer does make sense to me. And again, 63 was over here. Now, technically what you could have done, once you found opposite to be 63, you could have also done Pythagorean theorem. So just be aware that there's different ways to do these. But it's always the best idea to always resort back to your given and not use any newly calculated numbers. Pretty good on example 3? Let's try example 4. And then I'm going to add one more just to practice. Okay, so suppose your school is building a raked stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. A rake, which is the angle of elevation of 5 degrees or less. Okay, so it says if it's 5 degrees or less, it's generally preferred for the safety and the comfort of the actors. So they want us to test out and see if this ramp that they built, if it's within the range. So if it's less than 5 degrees. So again, I'm going to label my sides based on the given. So I'm looking for an angle measure now. So this is where I'm going to use the inverse function. But let's label our triangle. So here is the angle that they're asking us to check to see if it's less than 5 degrees. So in relation to this angle, the 2 is my opposite, and the 30 is my hypotenuse. So I know that for opposite and hypotenuse, that's going to be sine. So in order to find the angle measure, I could set it up like this. I'm really doing sine of x degrees is equal to opposite over hypotenuse. But when I go to do it in my calculator, I'm doing sine -1. And then if you can enter it as a fraction, you will. Or you would do sine -1 divided by 30, hit enter, and you should be getting 3.824, rounded to the tenths place, 3.8. It's less than 5 degrees, so this would be a good stage. Add a slide. All right, one to practice. The instructions are solve the right triangle. So here is my triangle. I'm going to draw it for you. That's kind of rough. Let's see. Here's my right angle. I'm going to call this A, B. Actually, I've been putting C at the right angle. ABC. This length is 14. This one's 16. So now, the one I did prior to this, I gave you an acute angle and a side. Now I'm giving you two side lengths. So remember, when we solve the right triangle, we're looking for the measure of angle A, B, and C. The only angle measure we know right now is that C is the 90 degrees. Also, when I'm done, and I'm going to label this as little a, this one as little c, and this one as little b. So when I'm done, I'm also going to be able to know what A, B, and C are. I already know B, it's 14, and C is 16. So the easiest thing to do first is I'm going to solve for the missing side. The way that I'm going to do that is Pythagorean theorem. So I'm going to go ahead and do A squared plus B squared equals C squared. I don't know A. B is 14, C is 16. I'm going to square 14, I get 196. I'm going to square 16, and I get 256. I'm going to subtract 196, and A squared equals 60. I'm going to use my square root button. I'm not going to leave it in simplest radical form because I'm going to keep using it. So the square root of 60 is going to be 7.74. I'm going to round to the tenths, so 7.7. So now I've found all three sides. Now I have to work on my two acute angles. And this is where we're going to use the shift key or the second key to open up an inverse. So let's go ahead and only use our original numbers. So my originals, remember, were here and here. I'm going to first find angle A. I'm going to label my sides of my triangle in relation to angle A. So in relation to angle A, little a is opposite, little c is the hypotenuse, and little b is the adjacent side. Again, I'm going to use the two that I circled in red. I'm going to use adjacent and hypotenuse, and that tells me I'm going to be using cosine. So I'm going to be doing cosine of A is equal to 14 over 16. Now, if it just asked you to leave it in the ratio, you would simplify this, and you would say it's 7 over 8. But because we're just figuring it out, we're going to do cosine -1, and you could leave it as the 14 over 16, and then hit enter to get your answer. So second cosine 14 divided by 16, and you are going to get about 28.9. 28.955. We're going to round to the nearest degree. So 29 degrees is angle A. Now, to find angle B, if you're confident in that answer, all you need to do is 90 minus 29. And the other missing angle is 61. Now, if you weren't sure, you could also go back and do another trig function. So for angle B now, this side is now opposite, but this one's still the hypotenuse. So now to find angle B, I could do sine. So sine of B is equal to opposite over hypotenuse. You're doing sine -1, 14 over 16. Once you do that, you get 61.044 rounded to the nearest degree. 61 degrees is angle B. Same answer I got when I just subtracted it from 90. So if you wanted to do sine first and then subtract this answer from 90 to get the 29, you can do that as well. Yes?
On my calculator, I'm getting the decimal.
Okay, double check, do tangent of 45, see if you get 1.
Yeah.
Okay. All right, are you doing sine -1?
Like, I have to type anything.
No, you should have a shift key. Here, let me come look. Okay, so now we found all 3 angles and all 3 sides. We have now solved the right triangle. Now, in your homework tonight, you're going to get questions at the beginning that they're going to say, let me just cover this. Let me add a page. So in the homework tonight, you're going to get a triangle like this, and it's going to have A, B, C, and it's going to have numbers. So for example, it might have, let's do 3, 4, 5. And they're going to say, which acute angle? Is it going to be sine of A or sine of B that will give you 3/5? So then what you're going to do is, I would set up and do both ratios to say, is my answer A or B? So if we do it in relation to A, this side is opposite, because remember, sine uses opposite over hypotenuse. So I just have to figure out which side is opposite to A would be 4. So this answer would be 4 over 5. Hi. And then sine of B, that would be 3/5. So when it asks you to figure out which acute angle it is, do it and put it in, and then you see that this one matches the answer they wanted you to do. Also in the homework, they're going to say, find the measure of D. So they'll say sine of D equals 0.5. And if they say find that angle measure, this is where you're doing sine -1. You put in the 0.5, you hit enter, and this answer is 30 degrees. So this is what you're doing. Then the end of the homework is solving the triangle, like I just showed you in the notes. So that is it for 9-6 and a couple word problems and solving right triangles. And coincidentally enough, my Algebra 2 class has a test on solving right triangles on Friday. So this doesn't go away. It comes back to you again next year. So that's it.